In this video, we're going to be going over area, circumference, and sectors of a circle. So this section will show you how to find the circumference and area of a circle, as well as find the length of an arc and finding the area of a sector. So let's get started. Now, the first thing we need to realize is before finding the circumference and area of a circle, we need to know the components of a circle. So over here, I have just a circle. Now, in a circle, the perimeter of a circle is called the circumference. And the circumference is just simply this line that actually makes the circle. The second thing I can have is, in a circle, there could be a line from any point which passes through the midpoint and back to the other side. Now, this line is known as my diameter. The last thing you need to know about a circle is I can have a line from any position going from its starting point all the way to the midpoint. And this line is known as my radius. Now, if you're observant, you'd be able to see that the diameter is actually equal to the radius's length times 2. Because if I drew the same radius from the other side, over here I'd have a diameter. So these are the three components you need to know about a circle, so we can get on to the next part: the circumference, the radius, and the diameter. So the first thing we're going to be learning is the circumference of a circle. So as stated before, the circumference of a circle is just simply the length of the line that actually makes the circle itself. The circumference of a circle is defined by the equation of c, where this is the circumference, is equal to 2 times pi times r. So this r is my radius, and this is a symbol known as pi. Pi is a special symbol used for circles, and it is equal to 3.142. You can use this number in your calculations, or you can just simply plug it in your calculator. It should be there on most modern calculators, and then use it to solve. If you don't know what pi is essentially the ratio between the circumference of a circle and its diameter. You can do more research about it, but for now, it's not really relevant to the topic. So anyways, this is my equation for the circumference of a circle. Now again, we know that a diameter is 2 times the length of a radius. So we can cancel out this 2 and cancel out this r, and we can also just say that the circumference is pi times the diameter. Both equations are correct, and both equations will work. So let's say I have a circle of radius length 3 centimeters. To find the circumference, all we need to do is write down our formula, where we can use the 2 pi r1. So c is equal to 2 pi r, and all we have to do is just substitute this 3 into the equation, as 3 is my radius. So c is equal to 2 pi times 3, which is equal to 6 pi. Sometimes the question will ask you to write it in pi form, where all you need to do is leave as that, or they might want the exact number, which is equal to 3 significant figures, 18.8 centimeters. So let's say I have another circle that has a diameter of 15 meters. So same thing here, we can use either of my two equations, whether it's c equals 2 pi r or c equals pi d, but since over here I just have my diameter given, let's do the c equals pi d one. So c is equal to pi multiplied by the diameter. C is equal to pi multiplied by 15. 15 is my diameter, which is just equal to 15 pi if the question is asking to write in pi form. Or when it's written down to 3 significant figures, that gives me 47.1 meters. And that is my final answer. Now let's go over to the area of a circle. Now, the area is just everything that's inside the circle. So the area of a circle is defined by the equation A, where A is the area, is equal to pi r squared, where my r is the radius. And that is all for the equation for my area. Relatively simple. So if I have a circle with a radius of 20, let's say 20 centimeters, we can just find the area by solving the area equation. So area is equal to pi r squared. Over here I can see that 20 is my radius, so all we need to do is just substitute 20. So it's going to be 20 squared times pi, which is in pi form equal to 400 pi. Or if they want the exact number to 3 significant figures, that is going to give me 1000, or actually in, let's say, simplified to 1 decimal point, 1256.6 centimeters squared. Remember not to forget the centimeters squared, as we are solving to find area. You may lose marks if you don't write it as squared. So let's say I have a circle with a diameter, remember, note that this is a diameter, of, let's say 14 meters. So my area is equal to pi r squared. Now I can substitute this 14 into my r, as this is a diameter. So to find r, I'll just do it here in the corner. To find r, 14 meters is my diameter, and we know that the diameter of a circle is twice the radius. So to find the radius, we just need to divide the diameter by 2. So the radius is equal to 14 divided by 2, which gives me 7. And now I can use the 7 to substitute into r in my area formula. So the area is equal to pi r squared, which is equal to pi times 7 squared. In pi form, that's 49 pi. Or the actual number rounded up to 1 decimal point is 153.9 meters squared. Again, never forget the squared. And that is all for the area and circumference of a circle. Now, we don't just have to worry about the area and circumferences of circles only. We can also have a semicircle, which is just half a circle, or something known as a quadrant, which is quarter of a circle. So let's start with the semicircle. Now the area of a semicircle is just simply the area of a normal circle divided by 2. That's all for the area of a semicircle, because a semicircle is just half a circle, so it's just the area divided by 2. As for the circumference, now we can't really say it's a circumference, because the circumference is the perimeter of a circle. So for semicircles and quadrants, we don't describe it as circumferences, but we describe it as perimeter, which is P. So the perimeter is just this line plus this line. So we'll label this line A, and we'll label this line B. Now this line A is known as my diameter. This is the diameter, because if I have a semicircle and I draw the exact same one to finish the circle, we can see that this line is my diameter. So in a semicircle, note that the straight line is the diameter. So the perimeter is just the diameter plus, now this line is just the circumference of a normal circle divided by 2. Because again, if I complete the circle, this line and this line both form a circumference. So the perimeter is just the diameter plus the circumference of a circle, which is 2 pi r divided by 2. These are the equations of the area and perimeter of a semicircle. Now as for my quadrant over here, something you need to know is that this angle in a quadrant is 90 degrees. As if we draw this 3 more times, we get 360, which is the angle of a circle. Now the area and circumference, or we can say perimeter of a quadrant, is essentially just the same thing as a semicircle, except we're dividing by 4 instead of 2. So the area is just simply the area of a circle, divided by 4. As a quadrant is 1/4 of a circle. 4 quadrants, so if we draw a quadrant over here, 4 quadrants form a circle. Now as for my perimeter, it is just this line A and this line B and this line C added up. Because remember, the perimeter is just simply all the sides added up together. So the lines A and B are the radius of a circle. Because if we draw a full circle using 4 quadrants, we can see that each line over here, which is the line in the quadrant, is my radius. Therefore, this line B and this line A are my radiuses. And as for my line C, just similar to a semicircle, it's just the circumference of a circle, but instead of dividing by 2, it's dividing by 4. So therefore, the perimeter of a quadrant is the radius plus the circumference of a circle, which is 2 pi r, divided by 4. And these are my 4 equations when it comes to the area and a perimeter of semicircles and quadrants. You don't really need to memorize these, as it is basically just common sense, but if you want to, you can go ahead and do so with no problem. So let's take a look at this question here. Feel free to try to answer it. If you're going to answer it, pause the video from now, because I will answer it in 3, 2, 1. So over here I have 3 shapes joined together. I have semicircle, which I will label A. I have a rectangle, which I will label B, and I have a quadrant, which I will label C. The question is asking for the area and the perimeter of the entire shape. So the first thing I can do to make it easier for me is to move around the lengths and add it to every single side. So in this rectangle B here, I have this 8 centimeters. If this line BA is 8 centimeters, that means this line CD is also 8 centimeters. Now you can see that this 8 centimeters acts on the line CD, which is also the semicircle. So that means that the radius of semicircle A is just 8 divided by 2, as A over here is my diameter, which is equal to 4 centimeters. Now let's do the same thing for the quadrants. If I see that my length CB over here is 6 centimeters, that means my line DA is also 6 centimeters. Now this line over here acts as my radius, because it is a quadrant. Now if this is the radius, that means the line DE is also the radius, which is 6 centimeters. So now that we have more lines, let's try to solve the area and perimeter of the entire shape. So to find the area of this shape, all we need to do is find the area of the semicircle, the rectangle, and the quadrant, and add them up. So the first thing I can do is find the area of the semicircle. So the area of a semicircle, as stated in the previous equation, it is just the area of a normal circle, which is pi r squared divided by 2. So that is going to give me pi times 8 divided by 2, because 8 is the diameter. So 8 divided by 2 is 4. So pi times 4 squared over 2. Therefore, the area of A is equal to, rounded to 3 significant figures, is 25.1 centimeters squared. Now as for my area of shape B, it is just the area of a rectangle, which is my base times height, which is just simply 8 times 6, and then we get 48 centimeters squared. And for my area C, it is a quadrant, and we've established that the area of a quadrant is just the area of a normal circle divided by 4. So it's just pi times 6 squared divided by 4, and that is going to give me, rounded up to 3 significant figures, 28.3 centimeters squared. And now that I have the area of 3 of these shapes, now to find the total area, all we need to do is add them all up together. So the total area is just equal to 25.1 plus 48 plus 28.3. And that is going to give me 101.4 centimeters squared. And that is my final answer for the total area. Now the last thing we need to do is find the perimeter. So let's start by perimeter A, which is the perimeter of shape A. Using the equation, the perimeter of shape A is the diameter plus the circumference of a circle divided by 2. So that's just going to give me 8 plus 2 times pi times the radius. The radius is 8 divided by 2, which is 4, over 2. 8 plus 2 pi times 4 over 2 is going to give me 20.6 centimeters. Now for my perimeter of shape B, we just have to add 6 by itself 2 times and 8 by itself 2 times. So it's just going to give me 6 plus 8 plus 8. 6 plus 6 is 12. 8 plus 8 is 16. 16 plus 12 is going to give me 28. And that is my answer for the perimeter of shape B. Now for my perimeter of shape C, you can just use the equation. So the perimeter is 2r, or you could say like the radius plus the radius, which is just equal to 2r plus the circumference of a circle divided by 4. So that's just going to give me 2 times 6, because 6 is the radius, plus 2 pi times 6 over 4, which is going to give me 21.4 centimeters. And now that I have my 3 perimeters, the total perimeter is equal to 20.6 plus 28 plus 21.4, which gives me... Oh wait, I actually made a mistake for the perimeter of the rectangle. I can't add this side and this side because this side's already been used to find the perimeter of the semicircle. So I did it wrong, but in the end, you should get for the perimeter is equal to 8 plus 6 plus 4 pi plus 6 plus 3 pi. And in the end, that gives you an overall answer of, to 3 significant figures, 42 centimeters. So ignore this, there was a mistake with my adding, sorry about that. You should get these for your 2 answers. Now this is going to be all for part 1. In the next part, we're going to be going over arc lengths and sector areas, and we're going to be going over more complicated questions with circles. I hope you guys understood this video. Have a good day, and goodbye.